Hi, I'm Travis. This is Handcraft Overlanding. In previous videos, I have put a secondary battery into the squirrely RAM, and I have put offshore charging or an onboard charger into the grocery getter. So today, I'm actually going to work on doing that on the squirrely RAM. It's a little bit different though. So in the grocery getter, there's a single battery. You plug it in, charges the battery fine. In the squirrely RAM though, the RAM actually has two separate batteries that are separated by a DC to DC converter. If you want to know how I built those or how I built that setup, go take a look at the video. It's actually not too bad. So part of that DC to DC converter actually has a relay in it that clicks on and off based off of power applied to it or not. The downside is that means that without doing anything fancy, I get to either charge the primary battery or charge the secondary battery, but not both. What I'm going to be doing today is I'm going to be doing that fancy bit. I'm going to be controlling it using an Arduino. I'm not very good at programming, but I can figure it out. There's a lot of good resources online, and I'll put some code together, and if you want the code, it's going to be down in the description, so you can go grab it and you can go mess with it. So essentially, what I'm going to be doing with the Arduino is I'm going to be monitoring the voltage on the leg on the inside of the primary battery, so your standard voltage of the system. So what it'll do is it'll detect whether it's above 14 volts or below 13 volts, and that will have the Arduino trigger to turn on or off the secondary DC power. Why do we want to do it that way? Well, I want to charge both batteries. I don't want to interlink the systems today. Basically, you can't really interlink them on both sides where you'd actually do the charging, because it's a deep cycle solar battery, it won't fully charge against the charging system unless you have a DC to DC converter. Kind of sucks, but batteries are kind of weird that way. So the Arduino will trigger the on-off circuit for the DC to DC charger. Why don't I always just run the DC charger and let it just do its thing? Because it'll drain the primary battery, and that's the purpose of the secondary battery being split off, because I don't want it to drain the primary battery. So the Arduino will turn it on, and it'll have two voltage sources. The first one's going to be from the alternator, and the second one's going to be from the onboard charge controller. That's another NOCO that I purchased. The NOCO, I think they called it the NOCO Gen 10 or Gen 1, which was the first one I installed into the grocery getter. They're now out with the Gen, I don't know, whatever. It's Gen 1 or Gen 2-A10. It's a single line charger that is up to 10 amp. Why did I go with the new one? Well, they don't sell the old one anymore, and the new one was still about the same price as the old one was, and it's about 30% smaller, and if you recall seeing underneath that rear seat, not a whole lot of room. So it's going to be a little bit different today. I'm not going to be doing so much on the install as I am going to be testing the voltage. So I got the Arduino Nano here. I have some bits and bobs. We got a breakout board, we got relays, we got more breakout boards, these are 12 volt to 5 volt buck converters, so I can convert the voltage on the truck down to 5 volts, which is what the Arduino runs on. We got resistors, we got a bench power supply. It's just a cheapie from Amazon. That's all we needed. So our first hurdle is going to be, so we know what we want to do. We know that when voltage exceeds 14 volts, switch on, or switch the relay on. If it drops below 13 volts, switch the voltage off. So those numbers might change around a little bit. I don't know. That's where I'm going to start on these points. So we know what we want to do. And the reason why I chose the Nano is because it's a small form factor. And also, it can handle up to 8 analog inputs, which is where our voltage level is going to be coming in from. It has 14 voltage in and outputs, which is really kind of cool. So what's going to happen is on the analog leg, we are going to monitor. I think I'm going to do it every half second. We're going to monitor the. We'll end up monitoring the voltage every half second because I don't need to sit there and just spam and click on as soon as the voltage starts charging. In fact, I want to put a lag time in there to say after 3 seconds, as voltage has been above 14 volts, turn on the charge controller or do a thing. So, also, another reason why I really like this Nano is I have those 8 analog lines, and eventually I want to. No, that's not it. Eventually, I would like to hook up this. It's a 3.5-inch screen that I'll end up getting a case made for. That I will display the truck battery voltage, the secondary battery voltage, and eventually I want to go so fancy as I want to see how much amperage is being used on each side. So when the charge controller's on, how much amperage is it pulling? And I bet you it's going to be less than 50 amp. On the inside, I want to see how much it's being charged. I want to see how much it's being drawn off of. I expect that the dash cam, I believe, is pulling like a 0.3 amp draw off of it, which isn't ideal, but it's what you get with a dash cam. And when I get more accessories, they're going to be on that leg as well. So let's go ahead and take a look at some of the code. But one of the first things I have to do is I have to build a voltage splitter. I think they're called voltage splitters. Anyways, the reason is the Arduino can only monitor up to a maximum of 5 volts, and that's broken out into steps of 1024, I think it is. Maybe it's 512. I'll take a look at the code and I'll correct myself if necessary. So what we have to do is we have to split the voltage. We're going to target 20 volt because it gives us a good round number to play with the resistor. So we'll split the voltage. We'll monitor the voltage. So that range will then be in the acceptable range for the Arduino. And then we can pick our relation to the numerical value output to our numerical turn on voltage. So that's where we're going to start. That's what we're going to do. So I'm going to do some screen captures so you can see what I'm kind of doing. But again, all the code's going to be down in the description. I'll give you a good view of what I'm doing here, and I think I have some breadboards laying about that I'll end up doing some soldering and building out that that voltage splitter and get everything mocked to it. So hopefully we'll get that done today. Today, you know, you guys know today's Saturday. Video's supposed to be out today. I might move these back to Monday. I don't know. What do you guys think? Anyways, let's get to it. Hey everyone, it's got late, and yes, this video isn't out on time, so I think I'm going to start pushing back my release date to probably Sunday or Monday. I'm not sure which. Anyways, so let me go over the setup that I've done. So using Arduino, I've made some code, and I'll go ahead and give a close-up to that code right now. So this is just a reminder that this is not a lesson on how to do Arduino code, because I'm not an expert. So I'm just showing you what I did. I'm sure there's better ways to do this, but this is how I did it. So to begin with, we set an integer for an array length. We're going to be using an array in order to catalog the last 6 measurements that are taken. Now we're cataloging these at 500 milliseconds, or half a second per. So that breaks out us to our target 3 seconds in order to identify the last 3 seconds stable voltage above 14 volts. Then we're going to declare our array. We're declaring a read indexer, and this is just taking our current reading. Our total is going to be the total, running total for the array, and then we have our average. We're also going to declare our input pin as A0, and we use A0 because this is the first analog pin that we can tie to. We then determine our pin mode using this phrase here. We're going to tell pin mode for pin number 2, so our digital pin number 2, and we're going to make it an output. So this is going to send an output signal across that pin, and it's going to be triggered via high and low. Now currently this script calls, or this code calls for a serial. Now this is only used during our testing. That way I can see the output on my laptop to see if I'm hitting the target values, making sure that the code works. This here's our for loop. This is declaring our integer, our position starts with 0, that so long as this reading is less than the array length, we can go ahead and add an additional 1 to it. Then what we do is we take the voltage array, the array that we've created up here, and this reading, which is the position of that, and we're zeroing all this out. Then we start into our actual loop, our actual code. So we can see here, first we're going to subtract one of the array positions out of our total. We go ahead and we read our voltage array, our position in the array, and we're going to write the data, the analog read, into that location. Now input pin, as we set up here, is A0. We'll then add that information to our running total, and then we're going to update our index by 1. And then we're going to check to see if the index is equal to or above the array length, which is set up here as 6. And if it is, we're going to go ahead and set the counter back to 0. And then that will allow us to continue this loop to write from the beginning to the end of the array, and then back to the beginning again. Then we're going to go ahead and calculate our average. So it's total divided by array length. Now, you could specify as 6 there if you would like, but if you have a single point where you can specify it up here, say 6, you can come in here, change it to 10. Now we're at 5 seconds, and we don't have any misguided, erroneous values that are throwing off our calculations. So we'll calculate our average. We're going to go ahead and print the average to the screen. And that's basically what we're doing. That was the first part of the code. And I'm going to go ahead and provide the source where I grabbed this code from, because I didn't make this up. I changed the value names so it made more sense to me, but I didn't write this. I kind of had an idea of what I wanted to do. Now here's the part that I came up with. We're going to say if our average, specified up here, is above 920, which is, again, 920 out of 1023 positions at over 5 volts, so this is roughly 14 volts. If it's above that voltage, we're going to tell it to write to pin 2, turn on. So this should turn on our relay on the DC-DC converter. And then we have the average, or the opposite going on here. If the average is below 853, which is, again, roughly about 13 volts, then we're going to turn it off. So this right here is going to turn it off if the vehicle is off, the alternator isn't running, and the shore power isn't plugged in order to preserve our primary battery. And then we have a delay of 500, or half a second. That's pretty much all the code is, and that's pretty much all this thing does. And it just runs this loop over and over and over again. So just a quick second, I wanted to talk about my breadboard layout. So as you can see here, on the left hand side is the Arduino. Here in the middle is my voltage splitter, and over here on the right is the buck converter. Building one of these voltage splitters is quite easy. As you can see here, we have our voltage in from the source we want to monitor. We have our ground, which grounds to both the Arduino and to our voltage source. And we have our monitoring line between two resistors that ties back to the Arduino. Calculating out the resistors isn't super hard. There's a lot of sources online. I'll go ahead and link to the one that I used here. But overall, these resistors, one's a 10k ohm resistor, the other one's 4700. From what I've been looking around for this particular layout, I want to monitor at 20 volts. A 30k ohm resistor and a 10k ohm resistor is more ideal, but I don't happen to have any. So I just want to get this project done, so once I get those new resistors in, which I've ordered, then I may upgrade that little board, because you can see later I made it into its own separate board, and I can just swap it out. Let's come back to the setup. Over here, this is a buck converter. So it'll take in any voltage up to 20 volt, and I have it tuned to regulate at 5 volt. That way we're not running the whole thing off of USB. You could do that. I just chose not to, because these things were actually fairly inexpensive. I want to say it was $1 each, maybe $2 each, right around there. Now, let's go ahead and see it. So, our light is off, our Arduino is on, not connected into the computer. If we take a look over at our readout, sorry for the flickering screen, but you can tell that we're at 12.93 volts. Now check this out. I'm going to slowly turn this up to 14, above 14 volts. So, not above 14 volts. I'm at 13.97 volts, and it still isn't on. So we're going to bring this up to 14 volts. A little bit past. And you see right there, turned right on. So we're at 14.3 volts. This thing's also only drawing 10 milliamps? Yeah, I'm going to go with 10 milliamps. I'll correct myself if I'm wrong. Which means it's pulling absolutely no power. That's just to turn on that light, and it's going to pull probably the same amount when it's only flipping on and off that relay. This thing draws almost no power, which is awesome. You can actually get these things down to run off of a little coin cell battery for like 30 days, 60 days. These things sip the power. So, now check it out. We all know that our vehicle alternator won't always just sit at 14 and above. So if it drops down to, let's say 13.3, truck still sees it as charging. So there is a concern that after you turn the vehicle off, there's a float charge on the primary battery. So the voltage doesn't drop that low, that quickly, which is okay. It's okay, because as we keep on coming down, so we're going to drop this down to 12.97. It's not perfect. I've been trying to do the math, and the numbers that I keep on coming up with the math keep on coming up different. But we're going to bring this down a little bit lower, and boom. So it's at 12.68. It turned off before then, but this is a very coarse adjustment, so it is what it is. Anyways, that is how I'm going to run the charge controlling in the truck. So no longer am I going to have a cable connected to an accessory in my fuse panel, which is under the hood. I don't like that. So that's no longer going to be there. This will handle all that work. So my next steps is going to be, I need to fit this all to a board. Either I'm going to use one of these, I'm going to do all my soldering on. I also have this guy, which is a terminal board for the Nano. Anyways, I'm going to probably use this for the Nano for all my connectors. This is going to be for the buck converter, and this guy right here. That should all fit into one of the project boxes I bought, which is right here. One of the project boxes I bought. Yeah, that'll hold it all. I'm gonna cut some slots along the sides to get that fitted. So that is where I am tonight. So the programming on this is all done. Now, there is some concern by me that the 5 volts here is not strong enough to trigger the relay on the DC-DC controller. And if that is the case, I have these guys, which are 30 amp relays. So what I can do is, because this guy won't be able to handle the 12 plus volts, what I'll do is I'll attach one of these relays, drop it down in the box along with everything else, and that relay, or this will trigger the relay, and the relay will trigger a 12 volt line between the positive 12 volt and the ground. Excuse me, positive 12 volt and the relay. So that's where I'm at this part of the project. I'm going to pick it up tomorrow. I might get a little bit of soldering done tonight. Who knows? We'll see. Hey, welcome back. So I got everything put into the box. We have the Nano connected to this breakout board with terminal screws. We have the 5 volt buck converter here, and then we have the voltage splitter. Now, I don't know what's going on with the voltage splitter. I know I did a crappy job building this on the circuit board, but my voltage is wildly fluctuating now. So back when we last saw it, this would turn on at 14 volts. Let's get this all the way up to 14. We're right around 14. Okay. So back to my little switch. It's not turning on. You know, if I bring this up though, I want to say it's like 14.3 now. Yeah, 14.3, 14.4. It'll now, it's now trigger on, which is, I mean, it's okay, but it's not what I want. Again, these numbers are all, I think I want these numbers. Anyways, so, and then its trigger off is somewhere around 13.4 now. Yeah, so don't know why those values keep on fluctuating. I am pretty dang sure it's either the voltage splitter or this thing is just way wildly off, which could be because it's a cheap Chinese unit. Anyways, so all we now have out of this little black box, a little project box, is going to be a positive and negative. These both fuel the voltage for the buck converter and provide the voltage source for it to test against. We have our test wire here for analog input, and then we have our digital out. So if everything goes well, this guy here should be able to trigger on and off the relay in the DC-DC controller. If not, again, I got these guys, which are relays themselves. And what I'll do is I'll cram that in the box, and there's plenty of room in there, really. And I'll get that set up. Anyways, I'm not going to show you guys in doing the installation. You've seen me do installation on that guy before in the shore power for the grocery getter. You've seen me do work on the electrical system in the pickup truck. So this was kind of more the part that I wanted to show everybody. So this guy will be doing all the work for multiple sources of power. And that's pretty much it. So I know, not super exciting, but thanks anyways for watching. And if you have any questions, please leave them below. I'll do my best to answer them. I'm not great at Arduino. If you guys have any comments on how I can get better, let me know. Anyways, thanks everybody. Have a great day.